Okay, this is 8.3, the Pythagorean Theorem. Most of you guys should be familiar with this lesson. I hope that you're not seeing this for the first time. Very useful function in mathematics. We use it all the time. So you get familiar with it today, you're going to use it right throughout high school and then moving forward as well. So the goal is to solve problems using the Pythagorean Theorem. I wanted to give you an algebraic representation of this theorem. I did draw this a little bit too high, it's gone into the title, but that's okay. We can still see what's going on here. So we have a triangle with side lengths 6 and 8, and we're trying to find out what the third side length would be. Alright, it's a right angle triangle. Remember the Pythagorean Theorem, very important that you guys remember this. It only works for right angle triangles. I'm going to put a star up here. Only for right angle triangles. So don't try and use it on any rectangles. Don't try and use it on any triangles that don't have a right angle in it. It doesn't have to be shaped like this. Remember, we could have a right angle triangle that's like this as well, right? It doesn't necessarily have to look like this. You got to try and envision if there's a right angle in it, the Pythagorean theorem can work. Okay? So here we have a triangle with a side length 6 and a side length 8. If we wanted to see what the square of those side lengths were, so you're just going to multiply, create two squares. So we have that side length of 8, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8 across, and 1, 2, 3, 4, 5, 6, 7, 8 down. So we have a square now. So that side length squared, b squared or 8 squared, is going to be 64. So there's actually 64 cubes in here. Okay, so if we drew that out. Likewise, if we had this side length that's 6, we squared it, so it's a 6 by 6 squared. You're going to see the number of units in there is going to be 6 squared, which is 36. Okay? Now if we finally took our last side and we measured it, we had 8 across, we squared that, so we go 8 the other way. Sorry, not 8. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 across and 10 this way, so we end up with 10 squared is equal to 100. And you could have found this out by counting these values and seeing that all of these, this square goes into this, and what's left is the same amount that's of number of units that are here. Okay, so there's an algebraic representation of it. If you prefer a formula representation, you can see what's going on, the same thing here. So we have that famous formula a squared plus b squared equals c squared. Filling in our side length values 6 and 8, adding them together we get 100. C squared, square root of both sides, so square root of 100 is 10. Square root of c squared is just c. So we have our third length is c. Now I have a problem with this formula. I feel like it doesn't actually help us that much when we're doing the problems, because you never know what side is A, you don't know what side is B, and most importantly, you don't really know the difference between A, B, and C. There's really no distinguishing difference. Okay, so people can get confused, and oftentimes, a lot of the time, people will sub in an A or B side for side C. So I prefer actually this formula. It's a little bit more, I guess, advanced in a sense. We have some subscripts here, 1 and 2. But basically what it stands for is side 1 squared plus side 2 squared is equal to h being hypotenuse, right, the hypotenuse squared. Santos, question?
C always the side opposite of the right angle?
That's right, yeah, it's the hypotenuse, yeah. The side opposite the right angle. Very good, yeah. And that's what's confusing about this, is it doesn't really call it out in this equation, a plus b equals c. I imagine it was created by an elementary school teacher, ABCs, learning your ABCs, so they wanted to make an easy formula as they could, so they just did it in order AB equals C. Yeah, Noah?
The two sides are touching the right angle. It doesn't matter which one you make A and which one you
No. Yeah, no, it doesn't matter. So the only reason I put the subscript is that you don't repeat the same one, but it could be S plus S. So either side, yeah, that's the other nice thing about S and S is that, you know, really it doesn't distinguish between A and B. It could be either side. The only reason we put, again, the subscript is to clarify that you can't have the same side repeated. All right, so side 1 plus side 2 equals the hypotenuse squared, all squared. So let's try it. So we have a question here. We're looking for the length of a wire that's holding up a wind tower. So this length here is unknown. We're given the other wire length, and we're given the height of the wind tower. So we can't go straight to find out the value of z because we don't know the value of y here. If we knew y, we could get z, but we don't know y. In order to get y, we need to find out what x is, right? Because we have this dimension all the way here. If we can find x, then we can find y. And then if we can find y, we can find z. All right? So that's the idea. We have to go in order. So the first step is to find x. So in order to find the side length, well, if this is a right angle, first of all, then this has to be a right angle also. Okay, so we know we're dealing with a right angle triangle. So to find x now, I'm going to use that Pythagorean theorem. Okay, it's actually a side length. It's not a hypotenuse, so you have to be careful here and sub it in for one of the sides. Hypotenuse, again, always being the side that's opposite the right angle. Okay, so we start with our formula. Side 1 plus side 2. Side 1 squared plus side 2 squared is equal to the hypotenuse squared. 5 squared, which is one of my sides right here, plus x squared is my other side, is equal to 13 squared. Okay, then I need to form a little bit of algebra, move things around. I leave x on the left-hand side because it's the unknown. I move the 5 squared over, so it becomes negative 5 squared. 13 squared is 169, 5 squared is 25. Careful that you don't square the negative sign. Okay? We know that negative 5 squared is equal to positive 25. Okay? But negative 5 squared like this, that negative sign stays out of the equation. Okay? So please don't make that mistake on your calculator. It'll be one of the few areas where you could get mixed up. Okay? So it does stay negative. Alright, and then finally, we take the square root of 144 and we get 12. Any questions there? Alright, once we have 12 for x, we can figure out the value of y just by subtracting 12 from 16.75. So we know y is 4.75. Now we have all the information we need in our final triangle. We have two sides. We need to find out the value of z. So we plug in those two sides for s1 and s2. Square them, and then take the square root. So we get 6.9 is equal to z. Okay, so the other wire should be 6.9 meters long. Don't forget, some of you guys are getting lazy in the test. You're not writing a concluding sentence. This was a word problem. If it's a word problem, you need to have a concluding sentence. All right, slant height. Slant height is the distance from the top of the base along the slanted side of the pyramid or cone. It's measured to the midpoint of the base side for a pyramid. So here's our pyramid. The slant height is from the very top to the very bottom. It's at a 90-degree angle, and it's measured to the midpoint on a pyramid. On a cone, it doesn't matter where on the base because it's equidistant from the very top, right? Because it's the circle. Okay, so that's what slant height is. So in a same as TP, it tells us that each beam is 81.7 meters long, and it touches the ground at 48.8 meters from the center of the base. So if this is our TP, this cone, the yellow dashed line is one of the beams. So it tells us this length, and it also tells us this distance from the center out to the beam. Okay, so I drew a top view here. If you're looking at the right down through the top of the TP, you have the center point to the edge of the circle is 48.8, and now I've drawn a side cross-section view through the TP. Okay, so it's asking us what the height is, so I put that value as x. We have the two side lengths. This is from the center. Remember, if this is our TP, we have a circle going around like this. So from the center to the outside is 48.8, and the length of the beam is 81.7. Also could be referred to as your slant height. Okay, we have all the information we need. It is in fact a right angle triangle. It doesn't tell us that, but we have to assume that when we're building something straight up from the ground, whether it be a building, a house, a teepee, a telephone pole, a windmill, we have to assume that it's a right angle from the ground. Okay, we're not going to build it up like the Leaning Tower of Pisa. Okay, you can make that assumption. Whenever it's a building or a pole or something coming off the ground, it's a right angle. All right, so again, doesn't specify that, but it's something that you need to assume. All right, once we have that information, we can use our formula, plug in our two side values, 48.8, and x is the unknown, equals our hypotenuse. Again, opposite from that right angle is the hypotenuse. So then we solve for x. The height of the TP is 65.5. Any questions there? Okay, I think this is review for most of you. So, in summary, there's our formula, a squared plus b squared equals c squared. Or, as I prefer, side 1 squared plus side 2 squared equals hypotenuse squared. Okay, gives you a little bit more information about where those variables should go. So the formula for a hypotenuse is this. So we're just taking this formula here now and we're rearranging it to solve for h. Okay? Likewise, the formula for the length of a leg or a side length of the triangle, again, we're doing the same thing. So we're solving for S1, we're moving S2 over, so it becomes negative, and we're taking the square root so we can do away with that square. Any questions? Okay, that's it for the lesson. Pretty clear.